Aging is a natural process of all living organisms. In humans, it represents the accumulation of physical, psychological, and social changes that are thought of as an inevitable process of health decline. Aging doesn't have to be that way. Recently, scientists argued that the rate at which this decline occurs can be slowed or even reversed. A growing number of scientists now believe the first person to reach the age of 200 has already been born. The idea of anyone living to that age is considered a fantasy by most people, doing so in good health even more so.
I think diet and exercise can get us beyond 80 for sure on average. Most people I know that have looked after their bodies live into their 90s in a healthy way, unless they've got really bad genes or they're unlucky. That's the minimum I think we can expect. Can we reach 150? I think that's not going to be for everybody, certainly, and we're going to need some major breakthrough in science to get there.
David Sinclair is a professor of genetics and co-director of the Paul F. Glenn Center for the Biology of Aging at Harvard Medical School. According to Sinclair, by slowing the aging process in human beings, we would also slow the natural decline associated with senescence and thereby extend into old age the health and functional capacity that is normally associated with youth.
If we were to define aging, at least as a medical condition, it would change the way we research and develop drugs for most age-related diseases. Because we don't regard aging as a disease, we've neglected it, at least for the last 200 years. And that's led to a lot of problems in our healthcare system and in our lives, where we're spending more and more time in a state where not all of our body is kept young for longer, our brains in particular. And it's becoming more and more common amongst my doctor colleagues, particularly in Britain, to write on the death certificate old age. But what I also want to argue here is that we've been focused for the last 200 years on why people, metaphorically fall off a cliff. But it's just as important, if not more important, to understand what drove them to the cliff in the first place.
Research done by Sinclair and many others have shown that the pace of aging is not inexorable or predetermined, but rather can be slowed and even reversed by a variety of approaches. They have shown that the level of NAD+ declines with age.
So what is NAD? So NAD, everybody learned about it in high school biology and then promptly forgot about it. It may have been the reason why people left science or became disinterested, because it is the most boring molecule in biology. It's used for about 500 chemical reactions. It's essential for life. Without NAD, we'd all be dead in about 30 seconds. But, we were forced to learn these chemical pathways. It's not that interesting. Things got really interesting when we realized that the body was sensing the levels of NAD to determine how it was doing and what the environment was like. So we now know when you exercise and when you are hungry, your NAD levels go up. It turns out that as you get older, NAD levels go down. And that's just a correlation, but what we've shown from numerous animal studies, rodent studies, an increasing number of studies in people is that what's going on is the NAD is turning on the body's defenses against aging through a group of enzymes that we worked on and have essentially spent 25 years figuring out. They require NAD as well. So the hormesis mediators, the enzymes that we think provide the health benefits of diet and exercise, are responsible for the longevity that you get when you lead a healthy lifestyle. Now, it's interesting to pause on this because we used to think that just running would make your blood flow better, and being hungry, you lost weight, and that's why you lived longer. But actually what I believe, and more people also believe, is that NAD and these other things that raise NAD are working, also resveratrol, are working because they're actively turning on the body's defenses against aging. And it's not a passive effect, it's not a coincidence. It's really just telling your body, times are going to be tough, fight against this onslaught. And NAD is one of the best things that I know to turn on these sirtuin defenses.
As part of the aging process, cells produce what is known as oxidants, or free radicals, which are toxic to cells and which can damage DNA and contribute to the aging process. Researchers in the field think that sirtuins can help prevent this kind of toxicity by speeding up the reaction by which harmful oxidants are neutralized in the body. Although most people equate biological aging to the general state of senescence, biological aging does not actually lead to death, but instead increases the susceptibility to many fatal diseases. Senescence, on the other hand, is caused by an accumulation of free radicals produced by the natural deterioration of cells. There is a mounting evidence that common aging-related diseases have a mitochondrial component, yet, surprisingly, little is known about what leads to the progressive loss of mitochondrial fitness during aging. Sinclair and his team are trying to identify new genes and signaling cascades in the human genome that control mitochondrial function. They are developing novel genome mining algorithms, using advanced sequencing and proteomic tools, and high-throughput screening methods to map the most complete network of mitochondrial regulators. This will provide new insights into fundamental aspects of mitochondrial biology and how mitochondrial defects may be prevented or corrected. Some scientists believe that the key to slowing the aging process is by targeting senescent cells, which contain a large number of mitochondrial DNA mutations. Others feel that more important are what we referred to as stem cells and cellular regeneration. That would delay aging and keep us healthier longer. At least that is the case in mice. Sinclair and his colleagues caution that it's not yet clear whether their findings will translate into humans. However, they say their proof of concept in mice shows that aging process can be reversed, and that some aging-related illnesses may be reversible.
There are major breakthroughs being made in the field all the time. The one that gives me a lot of excitement and hope is our ability now in my lab to reprogram cells to be young again. We have what's now a gene therapy, but eventually will presumably be a pill that literally turns back the age of cells, what we call epigenetic reprogramming. And that could be a treatment one day that literally turns the clock back.
As with all scientific research, there are various viewpoints within the field. The study of aging by the Sinclair Group is not without criticism. But what if we could stop or reverse aging? What if we could extend the natural process of living? Assuming we could live over 200 years, why would it be desirable to do so? Wouldn't lifespan extension just allow us to be sick longer? The argument made by Sinclair and others is that there is a huge misconception regarding aging. By slowing down the aging process, we are not necessarily prolonging the period of being sick, but rather protecting ourselves from dying prematurely because of age-related diseases. If we lived longer, we would have a healthier old age since we would be more protected from common ailments associated with old age that currently take so many lives. In the future, we will be able to protect our bodies against and treat both rare and common diseases, including mitochondrial diseases, type 2 diabetes, Alzheimer's disease, cardiovascular disease, and cancer. Controversy about life extension is mostly due to fear of overpopulation and possible effects on society. There are many skeptics who claim that if people lived longer than is currently possible, there would be a substantial overpopulation and the Earth would not be able to maintain its resources for such an extended population. Many scientists counter the overpopulation critique by pointing out that in the future, it will be possible to reactivate ovarian stem cells in vivo to treat premature ovarian failure, which could postpone or eliminate menopause, allowing women to space out their pregnancies over more years and thus decreasing the yearly population growth rate. Moreover, they argue that, given the fact that worldwide population growth rate is slowing down and is projected to eventually stabilize and begin falling, superlongevity would be unlikely to contribute to overpopulation. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.